In this class, we're going to be applying the Euclidean algorithm on two numbers at a time. So what does that mean? That means I'm going to give you two numbers and I'm going to say, tell me the GCD of those two numbers, and you'll have to use the Euclidean algorithm. Now, the way we're going to work it out is by doing simple division. As a matter of fact, what you're seeing right here on this page is similar to the division remainder theorem. Literally, if you start with the number n and the number d and you divide n by d, you're going to end up with some quotient and some remainder. And that's kind of what it looks like right here in the middle of the page. So this is guaranteed to happen by the division remainder theorem. And the process or the theorem here, the additional piece of information is that the GCD of n and d, the GCD of those two guys, is equal to the GCD of d and r. So that's the important piece of information that we would like to discuss here. So for example, let's talk about n equal to 15 and d equal to 4. If I divided 15 by 4, I'm going to end up with some quotient and also some remainder. As a matter of fact, 4 times 3 is going to be 12 plus 3 to get me back to 15. Now, according to this statement that we have in here, the GCD of the original numbers 15 and 4 is the same as the GCD of 4, which is a divisor, d, and the remainder. And in this case, the remainder is going to be 3. So when I'm doing the Euclidean algorithm later on, that's pretty much what I'm going to be doing. I'm just going to divide and keep dividing until I have a remainder of 0 eventually. And I'm always going to write in this order: n first, d afterwards, q after, and the remainder at the very end. This way I can keep track of all my work and all my numbers, and everything will be fine and less confusing. So let's practice by looking for the GCD of 330 and 156. So by the way, keep in mind that according to the previous slide, this will be n and this will be d basically. And so we begin by dividing 330 by 156. And again, keep in mind, I'm gonna reorganize it always with n first, d after, q after, and then finally the r. And as a reminder, this is the statement from the theorem. So 330 divided by 156 will be a 2 with a remainder of 18. And you can verify this with your calculator. It's not terribly difficult to check. So you can either divide 330 by 156, and then you'll end up with 2 point something something. Then you'll figure out that the remainder is 18. Or you could just multiply 156 by 2 and then add 18 to that to see that you get 330. Now remember, the original pair was 130 and 156, and according to my Euclidean algorithm, according to the theorem that we just mentioned, their GCD is the same as the GCD of 156 and the remainder. So I'm recording that off to the side so I can keep track of it. So at this point, I start with the new pair, 156 and 18, and I divide them. 156 is 18 times 8 plus the remainder of 12. And keep in mind that throughout this whole process, the q is irrelevant. We don't really pay attention to it so much as the original number n and d and the remainder. So again, because of this new line, we know that the GCD of 156 and 18 is the same as the GCD of 18 and 12. So we record that off to the side, and we continue by dividing 18 by 12, and we end up with GCD of 18 and 12 is the same as GCD of 12 and 6. And finally, 12 is 6 times 2 plus the remainder of 0. So there we go. The process is over because we reached a remainder of 0. So in other terms, the GCD of 6 and 0 is 6, which means that if we trace it back, since this guy is 6, that one will be 6, which means this is equal to it, and so on and so forth. Trace it back all the way to the top, which means that the original GCD that we're looking for is also equal to 6. And that's pretty much the end of the Euclidean algorithm. And you can see in 4 lines, we were able to determine the GCD of 330 and 156. Whereas if I were to factor the 330 and the 156, I would still be in the middle of factoring maybe at this point, doing the prime factorization, figuring out which factors repeat. Did I carefully count all of them? Did I organize it correctly? It's a little bit of a headache.